who is an environmental economist. Environmental economist with the MPCA. And I was thinking about this a little bit prior to our talk today, thinking, this is really where the rubber meets the road, isn't it? Where we all have great ideas on what we might do environmentally to make our world a bit better, but it's this kind of work that gives us an idea of what's possible and what is prudent, and maybe how much things are really going to cost us in the end. Everyone knows by now, of course, that chloride is a hugely important issue environmentally. And it is also no big secret that water softening is one of the big contributors to chloride in our environment. I have a water softener, and every time I put salt in that thing, I feel a little bit guilty. And so it's a real pleasure to introduce our speaker today, who's going to talk about the role of central water softening and the study that she's been doing with Elise Doucette and Scott Kaiser over the last few years, looking at, what is it going to take to actually reduce the chloride load in our environment with something like central water softening. So I'm really looking forward to this. And with that, I'm going to give it over to Baishali to give her presentation. Welcome to our Water Issues Seminar. Baishali, take it away.
Thank you, Mark, for that introduction. Great to be here. Good morning, everybody. As Mark said, chloride is a growing problem in Minnesota waters. Actually, it's also a big problem in national and waters and globally. The reason we are really concerned is because it's toxic to aquatic life. And it can also degrade drinking water sources. Water softening, especially with home softeners or ion exchange softeners, has been found to be a significant contributor to it, and it contributes basically high chloride loads to wastewater treatment plants, and from there it goes to water bodies. Cities are looking at maybe if there is an alternative solution to this problem, and we are trying to analyze whether centralized softening, that is softening the water at a centrally located drinking water plant, where it can be softened there and then it can go to households, if that could be an effective solution to this problem. So along with my colleagues, Scott and Elise, we examined this problem and found that centralized softening could be a viable solution. And so I'm going to give you an overview of this, of our project, our analysis, and some of our results. So the main reason chloride is a concern is because it is toxic to aquatic life, and mainly to sensitive creatures like mayflies, insects like mayflies, and freshwater mussels. It is also, once it's in the water, there is really no way to remove it. It's a permanent pollutant. And this is more of a concern for deep lakes, slow-moving rivers. Even when it gets into soil or groundwater, it can remain, the chloride level can remain high throughout the year because it would be retained in those specific reservoirs. And also many water bodies are already impaired for chloride. By impairment, mean that there is a water quality standard. It's 230 milligrams per liter. That's a chronic standard that Minnesota has adopted from the EPA. And there's also an acute standard of 860. But many waters, especially as you can see in this metropolitan area, are already impaired for the chronic standard. Groundwater also is like several groundwater wells in that region are also impaired or are at high risk. There is also a drinking water standard of 250, which is non-enforceable, but it is there. It's called a secondary standard, and it's there so that to prevent kind of unpleasantly salty taste of water. Right. So there is another reason chloride is a concern. It could pose a potential threat to public health by increasing the corrosivity of source water. Now, when source water becomes corrosive, that could lead to lead and copper leaching in drinking water infrastructure. And this kind of thing has happened before, for example, in Flint, Michigan and Washington, D.C. Current studies have found a significant statistical association between water corrosivity and exceedance of these metal leaching thresholds in drinking water systems. As I was talking about this groundwater chloride issue, that earlier it was believed that chloride mostly comes from road salt. So basically it is kind of expected that you will have high chloride loads during winter. But now we have found that chloride levels remains high throughout the year, and that points to storage in groundwater, as well as other significant sources of chloride loading, such as from water softeners. So the main reason water softening or home water softening is popular here is because Minnesota has very hard water. The water hardness, the US Geological Survey, the way it measures it is in grains per gallon as calcium carbonate. And about 7 grains per gallon, which translates to about 120 milligrams per liter, is considered hard. And you can see there a lot of places in Minnesota qualifies as very hard water. Now these home water softeners, which are called ion exchange softeners, the way they function is they use a resin base and a salt brine solution. So the salt brine solution goes through the resin base and they kind of exchange the hardness ions coming from calcium and magnesium with soluble sodium ions. And then the leftover backwash can contain these unused chloride ions and also the hardness ions, which then goes back to the wastewater treatment plants. Also, these ion exchange softeners have to be regenerated at intervals. So when that is done, that also contributes more chloride to wastewater treatment plants. So as a result of this, these ion exchange softeners in the aggregate, studies have found that that is actually the largest point source of chloride and the largest contributor to wastewater treatment plants. So 65% of the total chloride load to wastewater treatment plants actually comes from home-based softeners. And as a result of that, I don't know how the figures actually became identical, but it is correct. 65% of those wastewater treatment plants that are monitored for chloride are also going to get chloride limits because they have reasonable potential to violate chloride limits if they had it. Okay. So are you all with me so far? Can you all hear me properly? Yes?
Sound good, Baishali.
Okay, great.
Doing good.
Okay, so Now, once all these chloride goes to wastewater treatment plants, there is really no other option for wastewater treatment plants to comply with the chloride limits unless they install very expensive chloride treatment or end of pipe treatment. So here is this cost diagram for households in Minnesota. And you can see on the y-axis, we have annual cost per median household income. And on the x-axis is households per community. Right? So this line here, close to 0%, is the threshold of 2% of median household income, which the EPA uses to measure affordability. And as you can see, with chloride treatment at the wastewater treatment plant, it's very high cost. I mean, some of them are up to 70% to 80% of annual median household income. So it's indeed can be cost prohibitive for small communities, and it is a high cost for almost any household to have to pay fees for this kind of treatment. So to summarize, this is our problem here. Minnesota has very hard water. As a result, people use water softeners, which contribute chloride to wastewater treatment plants. And then because of this, wastewater treatment plants have reasonable potential to violate their chloride limits unless they install this extremely expensive end-of-pipe treatment. So cities are looking at alternative solutions to which would enable wastewater treatment plants to comply, as well as have a way to soften water for households at reasonable cost. So this last diagram is a cost calculation only for capital cost, though, for two centralized softening technologies. One is reverse osmosis, which uses a membrane to pass this water, and the other one is that uses hydrated lime to soften water. So lime softening and reverse osmosis. And as you can see that the cost for this evolve in a slightly different way. So for most households, reverse osmosis would be the more cost-effective strategy. But for very large cities, for reasonably large cities, you can have lime softening to be a more cost-effective option. And cities can use this difference to pick a technology which is more suitable to their needs. So this is what centralized softening actually does. It's a comparison between centralized softening and home-based softening. So on the left-hand side, you have water being softened at a drinking water plant and going to houses. It is already softened, so there is no need for additional home-based softeners. And then this water with no additional chloride is going to wastewater treatment plants. So the problem is solved. In the other case, you have point of entry ion exchange softening, and water from drinking water plants without being softened goes to households, and each household runs a home-based softener. And more chloride is contributed from there to wastewater treatment plant. So the two essential points here is that first, centralized softening avoids this additional chloride. And the second thing is it's also a more cost-effective and strategy which utilizes economies of scale. That is, the technology can be used at one centrally located plant and can be used for all households in an entire community. Whereas here, every every household has to use the technology, whatever technology they are using, and bear the costs for that. All right. So the goal was a solution that helps meet the chloride water quality standards for Minnesota, as well as providing this alternative solution for softening at reasonable cost. So our goal in this project was mainly to show or to examine, can centralized softening do this? Can it also be a cost-effective strategy? So there was this really good analysis, engineering analysis. It's called alternatives analysis, which was came out of in 2018, and they looked at a range of options for solving this chloride problem. And there are a number of technologies here, and they looked at 3 criteria. The first criteria is, will this technology enable sufficient chloride reductions which would let wastewater treatment plants comply? Second one is it technically feasible and can be implemented? That is it feasible? And the third one is it reasonable cost? So as you can see, only the centralized softening options, the lime and RO softening, actually meet the first 2 criteria, as well as its high cost. That's what we wanted to show here, how it compares to the alternative. The only other option that satisfies the first 2 criteria was this end of pipe treatment, where the effluent concentrate received was evaporated or crystallized and evaporated. So it's called ROEC. So it satisfies the first 2 criteria and therefore would have sufficient chloride reduction, but it's an expensive strategy, and mainly because it is extremely energy intensive. It is, however, technically feasible, and it's also can permit-wise, it is feasible. So we kept it in our analysis to compare with centralized softening. Now, apart from the 2 centralized softening options and this one, we also kept business as usual, or BAU situation, in which home softeners would be used, and there would be no additional chloride management strategy. So as a baseline to compare with the alternatives. Now, as you can see, no other technology here actually ticks all these boxes. So we are really left with only these centralized softening ones, and this one, the ROEC one, even though it's extremely high cost. So based on what we learned from this engineering analysis, we got this conceptual diagram of policy options. So the first option is this baseline option, where it's just the status quo and there is no policy. So this source, there is no, so we have home softener use. But we also considered if there, hypothetically, if there wasn't any home softener use, right? So this extreme right arm over here. So if there really wasn't any home softener use, there wouldn't be any environmental impact from this additional chloride, and there would also be no problem for wastewater treatment plants. However, the households, because Minnesota has hard water, they would have to use additional soap, detergent. Also, they would have to use lime away to ensure that their appliances function properly. But they would have some benefit from this. They wouldn't have as much corrosion to septic system because of chloride. Now the BAU option, where we just keep everything as is, let's say there would be an amount of environmental impact from chloride, say that is E. And because of the additional chloride, we'll also have a potential threat to public health from metal leaching in drinking water systems. So then if we move to the extreme left, we have this chloride treatment at the wastewater plant end. We, of course, can treat chloride there. But the cost of the technology, let's say that is X, and the environmental impact now that we are treating chloride. So the environmental impact is actually reduced. Let's say that is C, which is much less than E over here. And the potential threat to public health is partly averted. Now, the reason I say this is because when chloride is treated at the wastewater plant end, we only consider the chloride that comes through to the wastewater plants. That is, we are only considering households that are connected to city water and city sewage. There would be some households that use subsurface sewage systems, and from those systems, chloride, wastewater containing chloride would still flow to water bodies. So that's why there would still be some environmental impact in this option. Finally, centralized softening at the drinking water plant. They can soften the water and prevent all of the chloride from these systems to prevent them from going to the wastewater treatment plants. The technology cost is high, but it is much less than end of pipe treatment. The environmental impact is much less than E, but it is also less than what we have in the end of pipe treatment, because here we can prevent all of the chloride going to the wastewater treatment plant and to water bodies. And the threat to public health from this metal leaching can also be fully averted. For this particular problem and for this avoidance of home water softening that we are considering here. Okay. So the conclusion from here is this one. This alternative solution comes out as too expensive and it does not fully solve our problem, whereas this one is actually can be feasible. So we had then three alternative solutions to consider, well, two main ones. First one is centralized softening at drinking water plants with removal of home-based softeners. And then the second one is we have home water softening as usual, but we treat that wastewater for chloride. That is end of pipe treatment. And the last one is the baseline option where we don't do anything. So we actually got data from 84 cities. So the data that we looked at was a city having a wastewater treatment plant with high chloride loading. They should have this chloride, reasonable potential for chloride. And then we also looked at whether that city also had a drinking water plant with a treatment center. Typically, the drinking water plants with treatment centers are reasonable candidates for installing centralized softening. So we also got additional data on existing technology, softener costs, and softener removal costs. And then the way we kind of analyze this is looking at annual costs of both drinking water and wastewater for a household. And to do this, we considered capital and operation and management costs for the technology being considered, as well as its existing technology that the city had. And we annualized these costs based on what would be life of a typical centralized softening plant, say a 20-year lifetime. So we used a 20-year loan to annualize these costs. And then finally, we also looked at a lifetime perspective based on how long people would use a softener. So a typical softener lifetime would be 8 to 10 years. So we also used a net present value calculation to look at costs over time. So here is the first result comparing annual costs of chloride alternatives. So there are 4 graphs here and I'm going to walk you through it. So the black line here is again the 2% median household income threshold that measures affordability. The gray one is the business as usual scenario. The blue line is for centralized softening using reverse osmosis, and the green one is for lime softening, and the yellow one is for end of pipe treatment. So as you can see here, the end of pipe treatment cost is above all the other options for almost all of the time. So it shows that how expensive it can be. It's the most expensive technology around, and especially for small communities of up to 1,000 people, number of households actually. So it can be extremely high. It can be cost prohibitive. So, and that's one thing. And the other thing is the centralized softening options, mostly the reverse osmosis is lower than the lime softening option. And the reverse osmosis option is also very close to the BAU or business as usual scenario, which kind of tells us that, well, centralized softening is a high cost technology, but then people are already spending that much. People can already be spending that much when they use home softeners, and they are not getting any of the environmental or public health benefits while they are spending almost the same amount of money. Now, when we look at the costs over time, so over the lifetime of a softener, the picture kind of just clears up a little. It's more or less the same result, but the costs even out more, and so you can see distinctly the same results, but more clearly, rather. So based on this, again, we have centralized softening coming out as a feasible and cost-effective option for households. I have now a comparison for selected cities here for the costs. The costs are in thousands of dollars, and the cities are in ascending order of population. So you can see that RO softening is mostly the lowest cost alternative when we compare centralized softening with home softening and end of pipe treatment. But for very large cities like Rochester, you can have the lime softening option working out better. Now, this is again because of the way these technologies evolve, and for large cities, you can have reverse osmosis being the more expensive option. You also see another thing, the end of pipe treatment can be extremely high cost, and it's borne out more for really small cities. So you can compare the annual costs as well as the NPV with the other options here. So while these are high cost options, centralized softening can also be high cost. There are ways to delay or defray these costs. So for example, there are these state and federal funding sources available for cities. And there is a there is an organization called the Public Facilities Authority that works closely with state agencies, our agency, as well as the Minnesota Department of Health to provide low interest loans and grants to communities who want to invest in new infrastructure. So for example, they work with MDH on this drinking water revolving fund loans, which can be used for installing technologies like centralized softening. There are also these additional sources of funding, which the PFA works with the MPCA to administer. There's the point source implementation grant, which can pay up to 80% of the total costs of technology. And the Water Infrastructure Fund provides these very low interest loans for the same. Now, recent legislative changes have actually brought these sources of funding. They have made these more accessible for drinking water infrastructure projects. So total funding has also increased and access has also been increased. Well, our agency also provides some resources. They have a softener removal program as well as a rebate program that can help cities remove softeners and also reduce these low efficiency softeners. Finally, there is a variance, which is a temporary modification of a water quality standard, so that a city can have more time to comply, and in the meantime, they could build, say, a centralized softening plant. So far, 11 cities have applied for a variance. So here are the main takeaways from here. From our results, we found that centralized softening is by far the more cost-effective option compared to the only other alternative of end-of-pipe treatment. And among the centralized softening options, reverse osmosis was typically the more cost-effective, but centralized lime softening can also be cost-effective if the city is reasonably large. We also found that reverse osmosis is almost the same cost as the status quo or BAU option, with additional benefits, additional environmental and public health benefits. And the end-of-pipe treatment option is about 3 times as costly as CS lime. We also found it can be 4 or 5 times as costly as reverse osmosis. So there are a variety of benefits from centralized softening. Firstly, it's an efficient solution. So instead of contributing to the chloride problem and then trying to clean it up at the wastewater treatment plant, it just removes, it avoids the problem at the first instance. So it provides a softening option which does not contribute additional chloride to the environment. It also helps homeowners avoid the costs of home softeners, as well as the equipment they have to use, like salt, and also the regeneration costs. There are also economies of scale gains because centralized softening can be done in one place for an entire community, which, if the community is large enough, that means lower cost for households. These gains could be further increased if a group of cities, or maybe just 2 cities, share a drinking water plant. And it has these additional environmental benefits where they protect ecosystem services, which are benefits from nature, like clean water, recreation like fishing, wildlife habitat, and they have healthy aquatic communities like mussels. So freshwater mussels are actually sentinel species which protect other ecosystem services. So by reducing chloride and protecting mussels, it also means valuable ecosystem services are sustained for the future. And last but not the least, it protects long-term threats to public health from this lead leaching into the drinking water systems. Finally, there could be several stakeholders to this kind of an enterprise. So cities could find this type of analysis helpful in terms of the alternative options to chloride management and their costs. Environmental groups could find the water quality improvement and environmental benefits being helpful. And the general public, like homeowners, could have these additional benefits, as we have already seen in certain cities like Bloomington and Morris, who have installed centralized softening. And then industry, the water softening industry could find it a challenge. They may not like that we have the centralized softening option, but then they could take it as a competitive option where they can come up with a product which competes properly with centralized softening, so which makes things even better for everybody. With that, that's the end. Thank you very much for listening.
Great, thanks, Baishali. That was a really great presentation, very clear, and kind of highlights what we're looking at in terms of choices and problems and everything else. Yeah, thanks a lot for that talk. We have a lot of comments and questions that have come through on our chat, and maybe just I'll start by opening it with this. Someone asked, is water softening really necessary, or is it just a nice to have option? Do you want to rejoin that a little bit? Is this something that people really need to do, or is it something that, oh well, we could probably get away without it?
That's a really good question, Mark, and it depends where you are in Minnesota. I mean, overall, Minnesota does have very hard water, and it can be very useful to have water that, when you are taking a bath, or using washing dishes or running an appliance, to not have to have proper lather, or to not have scum build up in any domestic activity. So we can think of water softening as something very useful for people. But based on how hard their water originally is, it seems like water having 5 grains per gallon is an acceptable amount of hardness that people can use. If it is much more than that, it can be an unpleasant thing to live with day to day. So in that way, people can think of this as a useful thing to do. Also, it can reduce the lifespans of appliances, and that could be kind of costly for people. So people may not like that. So to have that. So.
Yeah, I have a little bit of a personal experience on that. I tried not softening my water once for a couple of months. I thought, well, maybe I'll just not do it. I have really hard water with a lot of iron and manganese in it. And literally within about a month and a half, everything turned orange. And that wasn't the worst of it. Then my appliances stopped working right. And within a month and a half, 2 months, I thought, oh yeah, this is not a nice to have thing for me. I really need to soften water. So yeah, from my experience, depending on what kind of hard water you have, it's really critical. Otherwise, you'd be basically camping and moving out of your house.
So this is Scott Kaiser. I've helped with Baishali on this paper. Another thing, centralized softening can be a useful strategy to deal with certain types of pollutants like radionuclides and gross alpha emitters. So, I'm stepping on the toes of our coworkers across the divide at the Department of Health, but lime centralized softening can be a useful strategy for protecting public health for some specific pollutants.
Great,
Yeah,
thanks, Scott.
another question that came across, and Scott actually rejoined this a little bit, but maybe it deserves voicing here. Kristen asks, does the agency have a break point for chloride concentrations? Knowing the cost of treatment and trends we are seeing in the streams and rivers, at what point will policies be required to limit household softening? Baishali, do you want to answer that a little bit? I know Scott answered it as well, but maybe that bears fleshing out a little bit more.
Right. So centralized softening, I mean, it would be fully effective only when all softeners are removed or mostly removed. I am not sure of when this kind of a policy, or even if it's going to be mandated, because that would require a lot of political will and changing public preferences throughout the board, which is an extremely difficult process. But there are options like what resources the MPCA is providing, to rebates for removing softeners or reducing the use of softeners. So that should be a kind of incentive for people. Also, they are providing information on proper salt management, so people are more aware of where all the salt is coming from and how much water softeners are contributing. This kind of the analysis that we did and the alternatives analysis that Scott and Elise had worked on before, this we also hope is going to give people extra information on the impacts of chloride. So that they are more aware of what water softeners can do and what alternatives are available to change that process. At the city level also, there are these additional sources of funding to defray the cost. So if that's a big bottleneck, this is a high cost technology, we cannot do that. There can be ways to defray these costs. And some of these are significant sources of funding. So I think considering all of those things would be helpful to make the transition more smooth, at least.
So this is Scott. I'm going to give a little anecdote here. So the city of Morris, within the past couple years, has installed centralized lime softening. And I was talking to the city manager for the city of Morris, Blaine Hill, and he worked on the project from start to finish. And he told me that this is the only project in his, 20 plus years of working as a city manager where people have actually stopped him at the grocery store and said, "Thank you for doing this project. The water coming out of my tap is so much better." It's just people, it's something people notice in their day-to-day lives. Morris had extremely hard groundwater or extremely hard water because they source their water from groundwater, and now everyone gets softened water at their house. And anecdotally, Blaine said that people in the city of Morris have just kind of, many people, not everyone, but have decided to just stop using their water softeners because the water coming into their house is softened and they just don't see the need anymore. So, a city like Morris has used voluntary strategies to reduce water softener use. But it seems like the majority of people have stopped using them in the city of Morris, and the city of Morris is now in compliance with their chloride limits. They've been able to reduce chloride concentrations in their discharge by several hundred milligrams per liter after the water softening plant went online.
One of the things that struck me a little bit, I was surprised at, was the your analysis that showed that RO, reverse osmosis, can actually be competitive in terms of cost in removing chloride. And we had several comments and questions kind of sorting this out on the chat side of the presentation. Saying, yeah, RO is drinking, RO at the drinking water source is expensive, but it can be affordable. Can you speak to that a little bit? I mean, I've always considered RO to be like, well, one of the best options you can in purifying water, but also considered it to be just extremely expensive. Has the cost of RO as a technology come down, or is it a matter of what you pointed out, I guess, in terms of comparing it, to what the other alternatives are? Does it just come out to be a more at least as competitive option? Because I was kind of surprised at that. Can you speak to that a little bit more?
So one issue with this is the technologies we looked at, or what actually we have to consider here. So one is the centralized softening, the other one is end of pipe treatment. End of pipe treatment being about 5 times as costly as RO, or 3 times as costly as centralized lime softening. It comes out that RO would be the more cost-effective option for most cities, and especially for smaller cities. Whether the cost has come down or not, I think these are comparatively new technologies. So I think Scott would be more able to speak to that, whether the cost has gone down over time or not.
Yeah, so just for context, lime softening is a technology. Oh my goodness. It's more than a century old, lime softening is, and it's been used forever to purify water. Drinking RO softening is a newer technology, and it's really only become kind of commercially available at the big scale in the last 2-3 decades. And RO softening has come down in cost. It's certainly a cost competitive technology for softening. That as I pointed out, it can still be expensive. You're not going to buy an RO plant for it's not. We're still talking millions of dollars. And
okay. So I have to ask. An RO treatment, of course, you're preventing chloride from getting into the finished product. What happens to the retentate that is going to be hugely high in chloride? What happens with that so that it doesn't get just washed into the treatment plant or into the river, right?
So Mark, I want to maybe Baishali we have some slides on this, and it wasn't included in this presentation. So if you reverse osmosis soften at the drinking water plant, groundwater in Minnesota has the water coming into the drinking water plant has no chloride, right? So then water going to people's houses, the softened water, it means that people no longer need to use water softeners, right? So
that's right.
The RO system, it adds no chloride, and it just allows people not to use water softeners, which reduces the chloride loading at the wastewater plant. RO treatment at the end of pipe at the wastewater plant is a totally different beast, because you have this highly concentrated brine that has a high amount of salt mass that needs to be basically, you need to boil all that water away and transport that salt to somewhere where it won't enter the environment again.
Right, I had confused those two. Thanks for clarifying that. Yes, right. Kurt Carlson asked, being the engineer that he is, any idea about how high chloride affects the highly popular PEX water supply systems? Any thoughts on that?
I think Scott would be able to speak to that. I wouldn't know. Sorry.
Scott.
So high chloride and water supply.
Yeah, Kurt asked,
PEX.
how does chloride affect the popular PEX? I think PEX, if I recall, that's the flexible plumbing supply systems, and wondering how chloride might destroy it, or what leaches out of PEX, if anything,
So
under
so
high
PEX,
chloride.
yeah, I think that's an acronym. You can think of it as the plastic pipe, like your PVC
Plastic
pipe.
pipe.
And that PEX pipe is unaffected by it doesn't really react with the amount of salt in the water. It doesn't matter what type of salt. Copper pipes, that the metal does interact with the amount of salt in the water. So the more, all things being equal, the more salt in the water in contact with a metal pipe, there's going to be more leaching. It's so it's the so that's something to know there. But what I would also point out is that there's not going to be high chloride concentrations in the water that people drink. So there's really not going to be that leaching in the water that you drink. The only time that high chloride concentrations occur in a house is in that discharge that goes straight to the sewer when that water softener brine is discharged. So it's not, whether a house uses copper pipe or PVC pipe or PEX pipe, it it can all of those types of pipe can provide safe water for drinking water.
One question I had, Baishali, was in figuring up the cost comparisons in this, and perhaps you mentioned it and perhaps I just missed it, but did you include any kind of cost estimate from the standpoint of environmental cost? In other words, the cost of business as usual on, the environmental services that, um, chloride-free water provides, or is that too complex to compare? Include in the comparison.
Right. So so centralized softening does have these additional environmental and public health benefits, and it to actually estimate those costs, first of all, they can be complex and difficult, but they were also kind of beyond the scope of our analysis here. We did provide estimates from the research literature in the paper that was published, but I mean, I can give you an example. So, for example, in Flint, for example, the public health disaster that happened, the cleanup costs after the event in averting expenditures and public spending went up to about more than $300 million. This is also not considering the medical bills of people who actually got lead poisoning. So you can think of that as something that can be avoided, can be prevented from using a system that does not add additional chloride to the environment. There are also a lot of environmental estimates, and this is more from protecting species like freshwater mussels, because they help protect other ecosystem services. There are also estimates from this willingness to pay studies where people say how much they are willing to do that. So it's considered, people consider clean water as a valuable asset. So.
Great. Yeah, I see. We have a lot of comments and questions and discussion going on in the chat that, of course, people can look at as well as listen into what I repeat here. Brian Noma mentions, yes, softened water can affect water quality and copper plumbing. This is the issue that MDH has been trying to bring to your attention. Several other comments that add to our question and answer time after your talk here, Baishali. If people want to take a look at the chat session, they can kind of follow the string, which is another great benefit of doing these remotely, actually. We are actually out of time.
Oh, okay.
Unless you guys want to add anything else to the comments that you see, or if anyone else has another question that we haven't really covered in some way, we can probably close up our talk here today.
So I just wanted to say that, I am answering these questions and I did not get time enough to look at the chat. So really want to thank everybody for listening and posting their questions. And Mark, if there is a way of sending me the chat window, that would be great. So I'll try to answer those questions as well.
I'll see if I can do that. Yeah. Okay.
Yeah, we are actually working with MDH and trying to address the comments that MDH has. So.
Great. And just as a reminder to people, these are recorded. So if you want to see the presentation again, you can certainly do that on our YouTube channel. And we can send the link to that if you're interested, if you don't have that already, as well as past presentations. A lot of good presentations are on there. So, Baishali, thanks so much for your willingness to do the presentation, and to, Scott for joining in with the Q&A session. Really interesting work and truly important stuff that you guys are doing. So, thanks again.
Thank you very much.
I'll see if I can